Hello everyone. I decided to record this tutorial because cubic equations seems to be quite a difficult topic, is judging from my previous experience. And that is why I decided to give you more insight into this problem. So the topic of today's tutorial, let's write it down. It's cubic equations. Cubic equations. Oh no, my camera is not good enough, I'm afraid. Better. Looks better now. Okay, so it turns out that there are two methods actually to solve the cubic equation. Let's start with the general one. So general method, which I wouldn't recommend you actually, because as you can see very soon, it's quite a long story. But nevertheless, it's a nice idea to know it just in case. So what is this general method? Let's write down the general form of cubic equation. It looks like a times x cubed plus b times x squared plus c times x plus d is equal to 0. So you can see coefficients a, b, c, d here. These are just constants, just numerical coefficients. And so what is this general form? As you may already know, probably, the cubic equation can have up to 3 roots. And our task is to find all these 3 roots, or maybe less, but maximum is 3 roots. It can be done according to the following algorithm. So the first step 1, is to guess the first root, guess one of the roots. Guess the first root. Let's call it the first root. Guess the first root, and let's denote this first root as not x but x0. But how can you guess, root? Because you can plug in any number here. Integers, of course, are preferable, but there is an infinite number of numbers. That is why we should have something more, reasonable. So it turns out that you may do your guess among these following numbers. So these roots x0 should be guessed only among the numbers which are given by the following formula. So nominator is the divisors of d. Divisors of d. D is this coefficient in this equation. And divided by divisors of a, where a is this coefficient in front of x cubed. So it will look like some educated guess. You still have to make several attempts to find the roots, but let's be inspired by the thought that if the root, nice root exists, some integer or maybe rational number, it's definitely among these numbers. So you will always guess these roots. What does it give you? So you guessed the root. It means that you guessed this term in the factorization of the left-hand side of the cubic equation. If we were able to factorize the left-hand side of this equation, we won't need any algorithms at all. We could see the roots immediately. But the problem is that let's pretend that this is quite a difficult equation. We can't find the way of factorizing the left-hand side. That is why we need to apply this algorithm. So it means, so if you found the roots, if you guessed the first root of this equation, it's equivalent to saying that you guessed one of the terms, which looks like x minus minus your number x0 in the factorization. So what is the next step? We still need to find the remaining 2 roots. Okay, and it turns out the step 2 will be long division. It's called, as far as I know, it's called long division. You need to divide this polynomial, cubic polynomial, which is in the left-hand side, by this guessed factor. So it will look like this. So as far as I know, you denote it in this way. So this is our initial cubic polynomial. It should be written here. And then it should be divided by this guessed factor, x minus x0. And you will get a result here, as far as I know. So here you will end up having some quadratic equation, by the way. Let's write it down as mx squared plus nx plus, I don't know, q probably, m and q. So, and then step 3 will be to find the roots of this cubic equation. These guys are going to be the remaining two roots of our initial cubic equation. Let's write down this third step. Find the roots of this quadratic equation, mx squared plus nx plus q, which you obtained by this long division of polynomial by polynomial. So this is how your algorithm looks like. And let's go over some examples just to get a sense of how it looks like. Okay, so here I have an example for you. Example 2x cubed minus 9 times x squared plus 7x plus 6 is equal to 0. Oh, sorry, I can't see. So this is my example. Example number one. Our task is to find the roots of this cubic equation, nothing else. As you can see, it's quite a difficult cubic equation because there's no way of factorizing it. At least we can't come up with the factorizing immediately. It means that it's better to apply our algorithm. So let's start doing first step. First step is guessing the first root. It's the crucial moment, crucial step. So what formula do we have? Divisors of 6, because this coefficient is 6, divided by divisors of 2. 2 is a coefficient in front of 3. And now let's write down all the divisors of 6. What are they? Plus minus 1, of course, because 6 can be divided by plus or minus 1. Plus minus 2, plus minus 3, and finally plus minus 6 itself. So these are divisors of number 6. Similarly, you need to write out divisors of 2, which is pretty similar, but a little bit easier. Plus minus 1, plus minus 2. And so how can you get numbers which are represented by this formula? Let's write them out, maybe some of them. So if the numerator is equal to 1 and denominator is equal to 1, you will get 1 divided by 1. This is 1. The next variant is when you take negative sign in front of it. So we are going to check this number, what next? 2 times 1, it will be 2, and minus 2, of course. Then 3 times 1, 3, not times, but 3 divided by 1. So 3 minus 3, and finally 6 minus 6. These were all variants when the denominator is equal to 1. Let's move to the next variant. When your denominator is equal to 2, you will have to do this procedure again. 1 divided by 2, it will be 1 half, and minus 1 half. Then 2 divided by 2 will give you 1 again, but we already written down 1. Then we have 3 times 2, 3 divided by 2, and minus 3 divided by 2. And finally, the last combination is 6 divided by 2, but it will give us 3, and we already. So we'll start our search among these numbers. What are we going to do with them? We're just going to take them one by one and plug into our equation, cubic equation, until we get the right answer there. Maybe we will be lucky with the very first root, who knows. Okay, let's try to take x0 is equal to 1. What do we need to do? We need to substitute 1 in this equation. 1 times 1 cubed minus 9 times 1 cubed plus 6, or 7 times 1 plus 6. What is it equal to? 2 minus 9. It will be minus 7. And these two guys will leave you 13. No, it's not equal to 0. Let's move to the next case. Next case is minus 1. Minus 1. Again, we have almost the same. Minus 1 cubed minus 9 minus 1 cubed plus 7 times minus 1 plus 6 is equal to what? This will be minus 2. This will be minus 9, minus because this is plus, minus 7 plus 6. So it will be, I don't know, minus 16 plus 6 minus 10, minus 12. Again, it's not 0, so it's not the root of our equation. Okay, let's move further on. Now the term comes from for x0 is equal to 2. Let's plug it in. 2 times 2 cubed minus 9 times 2 squared plus 7 times 2 plus 6. What do we have? This is 16. This is minus 36. This is plus 14 and plus 6. So these two guys will give us minus 20, and these two plus 20. Ah, look at this. We did find the rules. So it's all like so this is how this process of guessing looks like. It's a sort of educated guess. It's not quite, crazy procedure. So finally we found this root. It means that we guessed this factor in our future factorization, x minus 2. So consequently, it means that the next step will be division, this long division. Let's try and do it. I'm sliding out of view, I'm afraid. Camera is not. Okay, so step 2, long division, long division. What does it mean? It means that we need to take our initial cubic polynomial, 2x cubed minus 9x squared plus 7x plus 6, and it should be, I don't remember, and should be divided by x minus 2. So we guessed this term in our factorization. So this guy should be divided by this one. I hope you remember this process, this long division, polynomial by polynomial. But as for the first example, I'm going to do it quite in detail. Okay, so what do you need to do? You need to take the term with the highest power here from this polynomial, which is this term, divided by highest power term in this polynomial. So basically it's 2x cubed divided by x will give you 2x squared, and you write the result here, 2x squared. So what is the next step? You need to multiply this obtained result by these two guys. So 2x squared times x will be 2x cubed. Then 2x squared minus 2 will be minus 4x squared. So you write it here as far as I know. And then you need to subtract this result from this result, minus. Let's put minus here. You can do it term by term. So 2x cubed minus 2x cubed just cancels out, just disappears. We are not going to write 0 here. Okay, what about this guy? It was minus 9x squared minus 4. So minus 9 plus 4 will be minus 5x squared. And we are rewriting the remaining terms because we didn't have any like terms for them. Okay, after that, the whole process begins all over again. Again, you take this guy, this term with the highest power, and divide it by x again. So what is it going to be? Minus 5x squared divided by x will be minus 5x, and you write it here like the second term, like the next term. And again, you need to multiply x minus 2 by this guy. Just ignore completely the guy which you used in the previous step. So only minus 5x. So what does it mean? Minus 5x divided by x will be minus 5x squared. Then minus 5x again times minus 2 will be plus 10x, plus 10x. And again, just like in the previous case, we need to subtract the second row from the first row. Not row, but polynomial, of course. So this guy minus this guy just disappears. Then 7 minus 10, remember it's not plus, it's minus, because here will be minus 3x. And we don't have any like terms for this, so we are just rewriting it. Okay, it looks like we are moving to the end of the story. It looks like we are going to do it for the last time. Again, you take this term with the highest power out of the two and divide it by x again. Minus 3x divided by x will be minus 3, and you write it here as the next term. Oh, yeah, you still can see it. Okay, and now you need to multiply this guy x minus 2 only by minus 3. You should completely ignore the previous terms. So minus 3 times x will be minus 3x. Then minus 3 gets multiplied by minus 2, which will give you plus 6. And if you do this subtraction for the last time, you will see that it all canceled out. It means that the division is complete. And now you're interested in this result. So result is here. This is a quadratic equation, and it's going to be our last step to solve this quadratic equation. 2x squared minus 5x minus 3 is equal to 0. But as for quadratic equation, it's no problem to solve it. You know this discriminant and everything. So discriminant is minus 5 squared minus 4 times 2 minus 3. Maybe I'm writing it too much detail. 25 plus 24 will give us 49. And the formula for the roots is 5 plus minus square root of this is 7 divided by 4. So we have x is equal to 3, and the remaining is minus 2 over 4, which is minus 1/2. So these are two remaining roots. So our answer is as follows. So this cubic equation, as expected, has three roots. The first root was 2, which we sort of guessed. And the remaining roots are 3 and minus 1 over 2. So that's it. So that's how this general process, general procedure of solving a cubic equation looks like. As you can see, it could be practiced very easily, and it won't take you a lot of time actually during the test if you're well prepared, if you develop the skill, of dividing polynomial by polynomial very, very quickly. But nevertheless, I'm going to reveal you a big secret. All the problems which are given in your tutorial sheet and all your problems which you are going to face in your test, they are given, they are completed, designed in such a way so that you don't need to apply this algorithm. I'm just describing you this algorithm just in case. But what are you supposed to do during the test and maybe even during exam? So there is a second method which we can call factorization. Much easier, much easier. But sometimes it's hard, actually. That is why it's better to know two methods. So what does this factorization looks like? Let me give you some nice example. So x cubed minus 9x squared minus 9x plus 81 is equal to 0. So example 2. This is our example 2. As you can see, this is another cubic equation, but unlike the previous one, it looks much nicer. Because if you have a closer look at it, you realize that these four terms can be grouped into two subgroups. This group, the group 1 and group 2. What does it give? For example, if you pull out x squared from the first two terms, you will end up having x minus 9. And then it makes sense to pull out what? Minus 9 from the remaining two terms. And it will give you x minus 1. So you still have two terms. This is the first term, and this is the second term. So instead of four terms, initial four terms, you are now dealing with two terms, which look pretty nice. Look at this. You can factor out x minus 9 out of both of them. And you will have x squared minus 9. And finally, you can even take one more step. You can apply a very famous formula here, and you'll get this factorization, which means that you already know all the three rules. So x minus 9 is equal to 0, x minus 3 is equal to 0, x plus 3 is equal to 0, which means this, your first root is 9, the second root is 3, and the third root is minus 3. So that's it. You see how this method, how nice this method looks, and how much shorter it is compared to the previous one. But the problem is that sometimes the problem is that it's unusually nice equation. You can easily find this factorization. But if you look at the previous equation, what does it look like? Look at this, 2x cubed. Let me remind you of the previous example. So we were dealing with this equation, but you know what? Even though the coefficients are quite nice numbers, integers, very small integers, but there's no way of factorizing this equation. If you try to regroup, or maybe this is this, there's no way. It's extremely hard. There was the only method which worked in this case was this general method of guessing the first root, making this, doing this long division, and so on and so on. So so the moral from the story is that when you will be facing the problem of solving cubic equation, don't rush to apply this general method because it's relatively long. Just try to concentrate and find the way of factorizing it, because it always looks much nicer. But if you fail, don't worry, you can always apply this general method. And so, to inspire you a little bit, I decided to go over one example from our tutorial sheet. So first of all, where are you going to come across a cubic equation? the answer is if you're dealing with matrix 3 by 3 and you are asked to find something like eigenvectors, eigenvalues, and so on. So let's take question 1 E from, I think it's from tutorial 2, from tutorial 2, sorry. So in this tutorial, you're given matrix 3 by 3 matrix. 1, 2, 1 is the first column, 2, 1, 1 is the second one, and 1, 1, 2 is the third column. And the assignment in this tutorial for this problem is quite a long one. You need to find eigenvalues, eigenvectors, and even do something else, like maybe model matrix, maybe spectral matrix. But you know what? I'm not going to do the whole task. I'm only going to concentrate on finding eigenvalues, because that's exactly where you have to deal with these cubic equations. So let's compile this characteristic equation. And you already know that it's going to be cubic equation. And let's discuss how to solve it in the most reasonable way. Okay, let's start. So our assignment will be find eigenvalues only. Eigenvalues only. Find eigenvalues. So what do we need to do? We need to compile to build so-called characteristic equation. It could be easily done if you subtract lambdas from diagonal elements, and the remaining elements remain unchanged. So 1 minus lambda, 2, 1. This is our first row. 2, 1 minus lambda, 1, second row. And the third row is 1, 1, 2 minus lambda. We are putting vertical bars around it because it's determinant and equal to 0. So this is our characteristic equation. And now to solve it, we need to calculate this determinant first. I think that the best way is to expand it along the first row. So this element goes with plus, this is with minus, and this element will be with plus. You already know this, of course, because we've done it so many times. Okay, I need more space here. Okay, so let's start doing it. So the first element is 1 minus lambda. It should be multiplied by what? By the matrix, by the determinant of the matrix, which is left after crossing out the first row and the first column. I need to use something like this. Yeah. So our element was in the first row and the first column. That is why we cross out the first row and the first column, and we are left with this determinant of this 2 by 2 matrix. Let's write it down here. I'm doing everything in detail just to refresh your knowledge. Okay, so the next element in this first row is 2, but it has minus sign associated with it. So minus 2 times what? We are crossing out the first row again, but this time it's going to be the second column. So we are left with this matrix. You can see it, of course. So 2, 1, 1, 2 minus lambda. Okay, and the last element is plus 1 in the first row. We are crossing out the column and the third column in the first row, and we have this matrix. So 2, 1 minus lambda, 1, 1 is equal to 0, but I'm going to rewrite it. Okay, what next? Now we need to calculate this 2 by 2 determinants, which is pretty easy, of course. Let's try and do it. So 1 minus lambda, I'm rewriting it. And now I'm going to put brackets here because they look much more beautiful, less mess around it. So 1 minus lambda times 2 minus lambda minus 1. So this is my first determinant. Let's move to the second, to the next term. Minus 2 times what? 2 times 2 minus lambda minus 1. And finally, maybe it's better not to write this 1 because 1 multiplied by something will be the same something. Plus 2 minus 1 times 1 minus lambda. Okay, and now we need to do all this multiplication, simplification, and so on. And this is the most crucial moment. Maybe it's not a crucial moment yet. Let's just do multiplication in terms of these brackets first. So this guy, 1 minus lambda, will get multiplied by this guy first, and then it will get multiplied by minus 1. Let's do it like this. 1 minus lambda times 1 minus lambda again, times 2 minus lambda. And then we need to multiply this guy by this one, which will give us just minus 1 minus lambda. So here again, we can do multiplication inside these brackets. So it will be 4 minus 2 lambda and minus 2. So 4 minus, not minus 2, minus 1. 4 minus 1 will give us 3. I'm trying to do something in my mind, which is quite risky, to be honest. And here we have plus 2 minus 1 plus lambda. And now it looks like this term is the most difficult one. And you know what? The idea is that don't rush to do this multiplication. It's much wiser to leave it as it is and clean up these guys first. In this case, maybe you'll be able to do this factorization instead of this general method. Okay, let's try and do it. So minus 1 plus lambda, it will be written. This will be minus 6 plus 4 lambda plus 1 plus lambda. We need to simplify it even further. And I'm not doing anything to this term. So maybe this is the secret. Okay, so let's find like terms here. We have lambda, lambda, lambda here, which will give us how much? Plus 6 lambda. 6 lambda. And these guys will give us minus 6. And now this is the most crucial moment. Look at this. Of course, we prefer to do factorization because it looks much nicer, it's much shorter, and you will be pressed for time during the test, of course. That is why let's have a closer look. Let's imagine that this is our first term, very ugly term, but nevertheless it could be called the first term. And this is our second term. Okay. Of course, you can easily see that we can pull out 6, or maybe minus 6 is better. Look at this. If you pull out 6, we'll have a lambda minus 1. But it's better to have 1 minus lambda. That is why let's pull out minus 6 out of this term. And I'm rewriting the first. I'm still rewriting the first term again. Minus 2 lambda. So I decided to pull out minus 6. And you know what? I'm saved. I'm actually saved. Look at this. I still have 2 terms, but they do have a common factor now. And that was my intention, you know. So we are pulling out 1 minus lambda again. And again, I need to write this, my favorite brackets. So what is left from of the first term? Everything except for 1 minus lambda. So it will be 1 minus lambda times 2 minus lambda and minus 6. And finally, it's equal to 0. So we've been saved, you know. We didn't need to apply this general method. Look at this. This is the first term times second term is equal to 0. It could be solved very easily. So let me rewrite it to the new page. So I ended up with this equation. 1 minus lambda times 1 minus lambda times 2 minus lambda minus 6 is equal to 0. So in this case, this equation can be solved in this way. So the first term is equal to 0. It will give you lambda is equal to 1. The second term is equal to 0 will be 1 minus lambda, 2 minus lambda minus 6, but it's super easy equation. You can do this multiplication. We are going to end up with quadratic equation. It's a little bit blurred. Yeah. Okay, so let's do this. Lambda squared minus, I suppose, is 3 lambda plus 2 minus 6 will be minus 4. I'm running out of ink. This is really funny. Oh my goodness. Technical issue. Where's I don't have any pens. My goodness. This is really frustrating. Yeah. Looks like this one. Sorry. It's going to be blue, this one, but it doesn't matter, of course. Okay, so minus 4 is equal to 0. So it looks like I can guess factorization. Factorization is always better. So it will be lambda minus plus 1 times lambda minus 4 is equal to 0. Let's check it. So if we do multiplication again, we should end up with the same expression. Yeah, of course. So it means that we have 2 more roots here, minus 1, and finally lambda is equal to 4. So as you can see, this is the ideal way of solving these cubic equations. This is the fastest way. But you know what? What was the purpose of giving you this general form then? I'm going to analyze our actions, you know, during this during solving this equation, to give you the idea how can you do it in another way. So let's pretend that during exam you didn't see this wonderful thing that it could be factorized. No, maybe you were quite nervous, maybe you didn't have a good sleep, but you didn't notice just. And you succumb to the temptation of doing this multiplication. Let's pretend. Let's pretend. What will happen then? Does it mean that you will fail completely? No, of course no. There's always way out. So let's write down. Uh, this stage. So when you got this equation, but you didn't come up with this idea of factorizing it. Okay, let's write it down here. So this is like a second approach. So 1 minus lambda times 1 minus lambda times 2 minus lambda plus 6 lambda minus 6 is equal to 0. And you just didn't notice this wonderful thing. And if you don't notice this wonderful thing, you will have to do this multiplication. No way. Okay, let's analyze how you are going to act upon this situation. Okay, so let's do this multiplication. So let's multiply these two terms first. It will give us 1 minus 2 lambda plus lambda squared. And the second term, 2 minus lambda, is rewritten. Plus 6 lambda minus 6 is equal to 0. Okay, now we need to multiply it even further. So let's do it in turns. 1 times these two guys will be 2 minus lambda. So the next term, minus 2 lambda, gets multiplied by these guys. Minus 4 lambda plus 2 lambda squared. And finally, lambda squared should be multiplied by them. Plus 2 lambda squared, I'm not sure. Minus lambda cubed plus 6 lambda minus 6. Okay, now we need to find like terms, and the best idea is always to put these terms in a descending order of powers. So this guy is the main one, main term, it should be put in front. The next is our square roots. So this guy plus this guy will give us plus 4 lambda squared. Then the next term comes to lambdas, minus 4 lambda plus 6 lambda. How much? It will be plus lambda. And finally, numerical terms, 2 minus 6 will be minus 4. Okay, so you got a cubic equation. It has taken you longer time, but nevertheless, it still looks like it's possible to solve it. The only thing is it's better to get rid of this negative sign, and it could be done by multiplying the both sides by minus 2. Let's do it. It would look much better. Squared minus lambda plus 4. Look at this. We're quite lucky. So even if you didn't notice this beautiful factorization, you can do it later, because this cubic equation is quite a lucky equation, because you can see that if you regroup these 4 terms into 2 subgroups, you can easily do factorization next. I'm running out of space. Maybe I can write here actually. So what can you do? We can pull out lambda squared. I can still write here. No, it's better to write here. We can pull out lambda squared from these two terms, lambda minus 4. And we can pull out minus 1 out of these two. Minus 1 times lambda minus 4. And we immediately see that we now have two terms, but they have a common factor, lambda minus 4, which can be pulled out again. Lambda minus 4, and we will be left with lambda squared minus 1 equal to 0. And so we can immediately solve this equation. Lambda minus 4 is equal to 0, and this term is equal to 0. And you immediately see that this is our root 4, and this equation will give us two remaining roots, 1 and minus 1. So even if you don't notice this beautiful factorization is the very beginning, there are chances that you will get quite a beautiful cubic equation and still will be able to factorize it. But let's pretend even the worst case scenario. Let's pretend that you were so nervous during the test that you didn't even notice this cubic equation so beautiful. What would you do in this case? You will have to resort to our algorithm in this case, which is quite long, but nevertheless, it's like it may rescue you in this. Oh, sorry, I'm writing it here. So we are pretending that we didn't notice this beautiful factorizations. We didn't come up with any solution, and finally, you will have to. In this case, you will have to use our general method. Let's practice it. Let's practice it. So what do we do? What do we need to do as a first step? we need to guess the first root, which we denoted by x0. It could be calculated by this formula. So divisors of 4, do you remember this is 4, and divisors of what? Divisors of the coefficient in front of a cube, but this coefficient is 1. So let's write out all the divisors of 4, which are plus minus 1, plus minus 2, and plus minus 4. And as for divisors of 1, they are just plus minus 1. That's it. So, and now let's write out all the variants. So when we have 1 here and minus 1 here, my camera is not stable, I'm afraid. So if we had 1 here and 1 here, we get 1. 1 divided by 1 is 1. If, and the negative 1, of course. If we have 2 here and 1 here, we have 2, and of course minus 2. And finally 4 minus 4. So it looks like there is a chance that we can guess something. Okay, let's start checking every root one by one. So x0 is equal to 1. Let's plug it in. Oh, not x, by the way, it's lambda. Lambda, of course, sorry, it was lambda 0. Okay, let's plug in lambda is equal to 1 into this equation. So 1 cubed minus 4 times 1 squared minus 1 plus 4 is equal to what? 1 minus, oh, it's 0. So we immediately guessed the root. We are very lucky, unlike in the first example during this tutorial. Okay, it means that we can switch to step 2 immediately. So what do we need to do? What do we need to do during the second step? We need to multiply this cubic polynomial, lambda cubed plus 4 lambda squared minus lambda plus 4, and we need to divide it by the which factor? It corresponds to factor lambda minus 1. Do you remember from our first example? Okay, so divided by lambda minus 1. So the fact that we guessed the root 1 is equivalent to the fact that we guessed this factor in our factorization on the left-hand side. So our initial cubic equation should be divided by this guessed factor. Okay, let's apply this process. So we divide lambda cube by lambda, and we'll get the result, which is lambda squared. Then we need to multiply lambda squared by this expression one by one, term by term. So lambda squared times lambda will be lambda cubed. Then lambda squared times minus 1 will be minus lambda squared. And we need to subtract the second row from the first row, one by one. So this minus this just disappears. These guys will cancel out. Minus 4 plus 1, because minus 1 will be plus. Minus 4 plus 1 will be how much? Minus 3. Minus 3 lambda squared. And we are just rewriting these terms because they don't have any like terms here. Okay, now we need to repeat this process all over again. Again, we are taking this term with the highest power of lambda squared and divided by lambda again. So what is it going to be? Minus 3 lambda squared divided by lambda. It will be minus 3 lambda. We write it as the next term here. And now we need to ignore the previous result, which is lambda cubed. We need to multiply minus 3 lambda only by this guy, 1 by 1 again. So minus 3 lambda times lambda will give us minus 3 lambda squared, sorry. Minus 3 lambda times minus 1 will be plus 3 lambda. And again, we're subtracting the second row, second polynomial from the first polynomial. This minus this cancels out again as usual. And this will be minus 1 minus 3. Minus 4 lambda and plus 4 gets rewritten. Okay, the final step is coming. So now we need to divide minus 4 lambda by lambda again, which will give us minus 4. We write it here. And now we start multiplying lambda minus 1 only by minus 4. These guys are ignored completely. So minus 4 times lambda will be minus 4 lambda. And finally, minus 4 times minus 1 will be plus 4. And if you subtract this guy from this guy, you will end up having 0. It means that the division is completed, long division. Okay, so it means that we can switch to step 3. We obtained a quadratic equation here. Let's rewrite it here. Let's copy it here. And now all we need to do, we need to solve this quadratic equation to find the remaining two roots. No, last time I applied this formula with discriminant, but in this case it's so easy, it's so nice that I think that I can guess this factorization. Look at this. But let us check that my guess was right. So lambda times lambda will be lambda squared minus 3 lambda. Yeah, it's lambda squared. And so I have root minus 1, and the last root is minus 4. So that's it. As you can see, so why I decided to give you this example, I decided to show you, to get you inspired a little bit. Even if you, during the test, of course, everyone is in hurry, everyone is getting nervous. Maybe you, because of this, you might not be able to notice this beautiful factorization. Okay, don't get discouraged, just move on. If you don't notice anything beautiful about it, just do the whole multiplication, and you will end up having cubic equation, of course. There are chances that this cubic equation is quite beautiful. Ah, I lost all my, I don't know. I lost this equation. So if this cubic equation is quite beautiful, maybe you will be able to factorize it a little bit later on. But even if you don't, if you are not able to do it, there is a third method. There is a third general method with which will always rescue it. Maybe it's a little bit long, but if you practice your skills, like solving like 3 or 4 equations, there won't be a problem for you to do this long division and so on. So hopefully it will, I managed to inspire you a little bit. So that's it. So that's it about cubic equation. Okay, good luck for your test.